All right, welcome back. Mr. Baumer here, and today we are going to be in lesson 6.5 and 6.6. Okay, so you're trying to prepare yourself to come into class with some understanding of what our objective is. So make sure you're writing down the objective right here, which our objective today is that the student will be able to graph linear inequalities and systems of linear inequalities. Now, let's get a brief explanation, introduction before we get to the first page of the notes. What is a linear inequality? Well, let's think back for a second here. When we were graphing equations earlier in the year, we got an answer like x equals 4. Just one number. Solved, made that equation true. And then we later worked on inequalities where our answer was like x is greater than or equal to 2, which meant every number 2 and larger was actually a solution to the inequality. All right, so inequalities are going to involve certain symbols, and the key thing you need to go into this expecting is it's going to involve shading. When we do the graph, it's going to involve shading, a line and shading, a line and shading. So let's get started here. If you'll turn over to the first page, or you're probably already on the first page of notes, here we go. Now, let me make this bigger here. Over here, the vocabulary section. A linear inequality is similar to a linear equation, but the equal sign is replaced with, well, what are we replacing our equal signs with? With a inequality symbol. All right? We are replacing them with an inequality symbol. Such as, you remember that one, which hopefully your mind just said less than, and this one, less than or equal to, and then this one, greater than, and greater than or equal to. So it's going to look like an equation, a linear equation. It'll have an x and a y, but instead of having an equal sign, it's going to have one of these. Now, what is the solution of a linear inequality? Is any ordered pair that makes the inequality. We should by now at this point be associating the word solution with making true statements. All right. So let's look at this one. Tell whether the ordered pair is a solution of the inequality. Is the ordered pair 4, 5 a solution to this? Now, of course, we remember from down here, solutions make true statements. So if I replace y with the y value, because this is an x and a y, so if I replace y with 5 is less than replacing x with 4 plus 1. 5 is less than 5. Now, is that true or false? 5 is not less than 5. All right, 5 is the same thing as 5. So this is a false statement, so it is not a solution. It is not a solution. Now, here, is 1, 1 a solution to this linear inequality? Well, let's replace, again, we have x and y here. Let's replace y with 1. And replace x, in this case, with 1. So we get 1 is greater than, 1 minus 7 is negative 6. Is that true or false? Well, that's true. But again, our answer is not true. Our answer is, yes, it is a solution. It is a solution. Now, in both of these cases, they gave us the ordered pair to try. Well, what if they don't give us the ordered pair to try? What if we need to show all of the solutions to one of these? And that's really what we're going to focus on the next page, which is how do we graph linear inequalities. All right, so if you'll turn to the next page, you'll see here it's asking us to graph the inequality. And I give you some steps over here that we're going to follow. All right. In order to graph linear inequalities, we will, first of all, graph the boundary line. All right, now, what the heck is the boundary line? Well, all you're going to do is take this equation that we're given, or this inequality rather that we're given, and make it an equation. So all I'm doing is replacing that symbol with equal. And that's my boundary line. So that's the first thing I need to do. I need to graph the boundary line. Now, we'll recognize from our last unit that this boundary line, the y-intercept, is -3. So, make it a little bigger here. The y-intercept of that is -3. So -1, -2, -3. And the slope is 2. So I'm going to go up 2, right 1. Up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1, etc. All right, now I need to graph that line, but I needed to make a decision. Over here, I need to make a decision if my boundary line is solid or dotted. And here's the rule. If it's going to be solid, our symbols in the original problem up here, we want to look at this symbol right here, and that tells us if it's going to be solid or dotted. It will be solid if our symbol is less than or equal to or greater than or equal to, and it will be dotted if our symbol is less than or greater than. So the key here is if it has an equal to part of it, then it's going to be solid. So in this case, it does have an equal to part of it. Our line is going to be solid. So if I graph that line there, right there. All right, so I've done part one. I've gotten my boundary line on it. I've decided if it's solid or dotted, and I've graphed it. Now all I have to do is decide which side of your boundary line to shade on. Remember when we started, I said these are going to involve shading. Now, how do I decide where to shade? Now, a lot of students make the mistake of thinking that this symbol automatically tells them where to shade. And it does, but under certain circumstances. So I'd rather avoid you falling into that trap. And I'd rather us focus on the fact that we want solutions to make true statements. So we just need to decide, do the ordered pairs over here make true statements, or do the ordered pairs over here make true statements? And a great point to test, right, what I'm pointing out to you down here, is that a great point to test, if you can, is 0, 0. And by if you can, I mean if your boundary line actually went through 0, 0, you wouldn't want to pick that point. You'd want to pick something above it or below it or to the left of it or to the right of it. But right now I can test this point, and I can see if it's true or not. So let's do that. This ordered pair is 0, 0. So if I do this, if I say 0, because that's the y value, equals 2 times 0, which is the x value, minus 3. So I get 0 equals, or I'm sorry, I wanted my original problem. Sorry, this should have been greater than or equal to. All right? 0 is greater than or equal to -3. Is that true or false? Well, that's actually false. Right? So right here, that point right there is false, which means all of the ordered pairs over here don't make the original problem true. So our solutions must be on this side. So we actually want to shade on this side. So everything over here gets shaded. Everything to the right, or underneath, depending on how you're looking at it, of our boundary line gets shaded. Now, what does that mean? Well, that means that any ordered pair I pick in that green section, any ordered pair I pick over here, would make my original problem true. And it would also mean that any ordered pair I pick over here would not make it true. Now, what about points on the boundary line? That's a key thing we need to focus on. What about points on this line? What if I'm right there, or right there, or right there? Do those make it true? And down here at the bottom, here's some notes. Are you a solution if you are on a boundary line? Well, if you're on a solid boundary line, you are a solution. You will actually make it true. If you're on a dotted boundary line, though, you are not a solution. So let's come back here, and it asks us, is -1, -1 a solution? Well, just like on the last page, we could plug -1, -1 into the original problem and see if it's true or false. Or now that we have all of the solutions shown, we can really just look at our graph. Is the point -1, -1 a solution? Well, it's not in the shaded region, so it is not a solution. Or no, it's not a solution. Now, what about 0, -3? 0, -3. Well, we'll notice that, hey, wait a minute, that's actually on the boundary line. Well, what type of boundary line is it on? It's on a solid boundary line, so it is a solution. All right, so again, let's just really review really quickly here. How do we graph linear inequalities? We graph the boundary line, which just means change this to equal sign. And then we have to decide if our boundary line is solid or dotted. Then we have to decide which side to shade on. Not so bad if you're good at graphing lines. It's not too much extra work. Now, what if, instead of looking at a single linear inequality, what if we are looking at a system of linear inequalities? How are we going to graph a system of linear inequalities? Well, it's just two linear inequalities. So we need to graph this one, and we need to graph this one, and we need to see where they overlap. So, a solution of a system of linear inequalities are the ordered pairs that satisfy all the linear inequalities in the system. So, we need to come up with a bunch of shading that shows me where all the ordered pairs are that make both of these true. So, let's get started. How do we graph this one? Well, it might be easiest if we convert this to slope-intercept form. So, the y-intercept is 1, the slope is -3. It means I can go up 3, and I got to go left 1. Up 3, left 1. Up 3, left 1. Now, is that going to be solid or dotted? Well, my symbol here includes the equal to word, so it's going to be solid. Now, I need to decide where do I shade for this one. Well, I'm going to shade this test 0, 0 here and see if it's true or false. 0 is less than or equal to, this becomes 0, 1. So 0 is less than or equal to 1. That's true. So in this case, I'm going to be shading everything down here. I got over the line a little bit. I'll come back and correct that in a second. But you'll see we're shading all of this. Now, we still need to do the other one. All right? We still need to do the other one. Now, let's look at that inequality right here. It's already in slope-intercept form, so to speak. So that one should be pretty quick to graph. Let's just look at this. We have a y-intercept of 2, and we have a slope of 2. So I'm going up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. And I need to decide, is that solid or dotted? Well, I look at it, I notice that the symbol doesn't include the word equal to, so it's got to be a dotted line. So I'm going to draw a solid line here first, and then I'm going to come back and fix it. So I can now tell that line to be dotted. So I still need to decide where to shade on this one. And again, I'm going to test the origin. 0, 0. 0 is less than 2 times 0 is 0. So I get 0 is less than 2. 0 is less than 2 is true. So this side needs to be shaded. So get my highlighter. And this side, let's do green. So everything below here needs to be highlighted green. Now, the real question is, well, what's the solution to the system? I know that the green represents the solution to the second linear inequality, and I know that the yellow represents the solution to the first linear inequality. But the solution to the system, it turns out, is this right here. It's really just this area right in here, because it's where these two shadings overlap. All right, we're really talking about this area in here is the solution to the system. That is the area that would make any ordered pair in that area would make both inequalities true. So on your own, I want you to decide, are these 3 points solutions to this system? Not do they solve one of them, but do they solve both of the inequalities, the linear inequalities making up this system? So do that, come into class with a little bit of knowledge about what we're doing, and we'll go from there. Thank you. See you tomorrow.